students, welcome to Wisdom Academy YouTube channel. In today's video, we will learn about mirror formula. So till the previous video, you have seen what is a concave mirror, what is a convex mirror, what are the uses of these mirrors. I said you in the previous video itself that you must get thorough with all the image formations. Like whenever you hear an object is placed at this much location, you must have an imagination inside you where the image will be formed. For example, if the object is placed at C in front of a concave mirror, then the image will be formed at C of the same size, real and inverted. This calculation your mind should make automatically when you hear the object location. Right, so today we are going to discuss about the mirror formula. So before I enter into the mirror formula, I will tell you about the sign conventions. So before understanding what the mirror formula is and how to solve numericals based upon mirror formula, you must know what a sign convention is. So for that, this is a concave mirror and this is principal axis. Somewhere here I am drawing center of curvature, here I am drawing focus, and let at this point be pole. So whenever you keep an object anywhere, suppose I am keeping the object beyond C, let me assume it will be here. So this distance of the object from the pole, listen to my words very carefully, the location of the object from the pole, this distance is known as object distance, which is represented by U. So what is U? U is the object distance. So we know when the object is placed beyond C, the image will be formed between C and F somewhere. So I am just drawing. Since I know how it will be formed, I am not drawing the ray diagrams. Right. Now this is the location of the image. Location of the image from the pole is known as V. That V means image distance. You would have studied about U and V in motion chapter in 9th standard, and U was initial velocity, V was final velocity. But in light chapter, U will be the object distance, V will be the image distance. And already you know focus. So the distance of focus from the pole, this distance is known as focal length. Small f, that is called as focal length. So I will repeat once again. U is the distance of the object from the pole, known as object distance. V is the location of the image from the pole, known as image distance. And F is the location of focus from the pole, is known as focal length. Now why I am stressing this from the pole always is because it will help you in understanding the sign convention. So basically there are two sign conventions. So sign conventions, there are basically two. What are those things? Please write. So the first sign convention says that all the distances which are measured along the direction of incident ray are taken as positive. I will repeat once again. All the distances measured along the direction of incident ray are taken as positive. Written? Then you write, and all the distances measured against the direction of incident ray are taken as negative. I will repeat, all the distances measured against the direction of incident ray are taken as negative. That is the first sign conventions. Okay, now I'll tell you what is that. So it says that in this diagram, this is the direction of incident ray, isn't it? This is the direction of incident ray. Someone can ask me, sir, direction of incident ray will always be from left to right? Not necessary. Same condition if I would have made like this. This is the concave mirror only. Here I have F and here I have C, and I would have kept the object here. Then in this case, this will be the direction of incident ray. The direction of incident ray is purely based upon how you are drawing the ray diagrams. So in this case, what I have drawn, direction of incident ray is from left towards right. Now when I said you about object distance, I said you distance of object from the pole. So how we are measuring? We are measuring against the direction of incident ray. So obviously in this case U will be negative. Similarly, Distance of image from the pole, it is measured against the direction of incident ray. This will also be negative. And even focus is measured from the pole. This will also be negative. Now some of you would have got the thinking now. In that case, wherever you keep the object, whatever the case may be in front of a concave mirror, always U, V and F will be negative. No, my dear students, it is not like that. Because remember the condition when the object was kept between F and P. When the object was kept between F and P, let us draw the diagram for you. This was P, this was F and this was C. When the object was kept here, first ray went parallel to principal axis, passed through focus, second ray was passing through center of curvature, went in the same path. When extended in the back side, the image was formed somewhere here. So in this case, this will be U, object, this will be F and this will be V. So here U will be negative, F will be negative, but V will be positive because this is the direction of incident ray and a distance what you are measuring is also in this direction only. Do you get me? So there is no rule that always the U, V and F value will be negative for the case of a concave mirror. It may be negative, it may be positive. So only in this case I get the V as positive here. Let us see what happens in the case of convex mirror. So see, this is a convex mirror. Now what I am doing? This is the principal axis. I am keeping the object somewhere here. Now this is the focus, this is center of curvature. I know that if the object is kept anywhere in front of the convex mirror, the image will always be formed between P and F, that will be diminished and it will be virtual and erect. So see here the distance of the object from the pole is somewhere like this, U, this is V and this is F. This is the direction of incident ray, isn't it? Because the ray goes like this and goes. This is the direction of incident ray. Now here what about the sign convention? See, U is measured against the direction of incident ray. So U will be negative, isn't it? F, this direction of incident ray, F I am measuring like this, positive. V, positive and always positive. So remember that in the case of a convex mirror, U will always be negative, V and F will always be positive. So you can just remember it because there is no case where V can become negative. Now write the second convention. Second convention says that all the heights measured above the principal axis is taken as positive. I will repeat once again. All the heights measured above the principal axis is taken as positive, whereas all the heights measured below the principal axis is taken as negative. I will repeat once again. All the heights measured below the principal axis is taken as negative. What it means, let us take two examples, one of a concave mirror, one of a convex mirror. This is a concave mirror and you take the case, any case, object is kept between C and F. So where the image will be formed, we know one ray will go like this, pass through here, one ray will go like this and becomes parallel to principal axis, it will meet somewhere here. So this will be the image formations, this will be AB and this will be A dash B dash. So here this height is above the principal axis. I am representing by HO. HO means height of the object, height of objects. Some books will also write it to be H, both are the same thing. And this is HI. HI means height of the image, height of image. Some books will write this as H dash. Okay. So here HI will be negative, HO will be positive. Why? Because it is below the principal axis, it is above the principal axis. Can HI be positive? Yeah, it can be positive. Take the case of convex mirror. So in the case of convex mirror, wherever you keep the object, definitely how the image will be formed, if you recall, it will be formed somewhere here. So here see HO and HI both are positive. We just want to see which are the heights above the principal axis, take positive. Below principal axis, take as negative. So we have learned from the sign convention that all the distances measured along the direction of incident ray are taken as positive, against the direction of incident ray is taken as negative. All the heights measured above the principal axis is taken as positive, below the principal axis is taken as negative. Now what the mirror formula is? Mirror formula relates u, v and f in a equation. The equation is 1 by f is equal to 1 by v plus 1 by u. 1 by f is equal to 1 by v plus 1 by u is the mirror's formula, and there is a formula of magnification. Magnification means ratio of height of the image to height of the object. So hi by ho, also called as h dash by h. So if they ask you what is magnification, it is the ratio of height of the image to height of the object, and the formula is h dash by h is equal to minus v by u. This is formula of magnification. So magnification is equal to, hi by ho is equal to minus v by u. These two are the formula which are known as mirror's formula, and they are used in solving the numericals based upon all these concave and convex mirrors. Let us see one question which will help us to understand the mirror's formula better. The question goes like, a concave mirror produces a real image 10 mm tall of an object 2.5 mm tall placed at 5 cm from the mirror. Calculate the f and v. Whenever this kind of questions are given to you, you must make an imagination of how the object is and where the image will be formed. So here one thing is sure, it is a concave mirror and you are getting a real image. Definitely the object is not between f and p. It will be somewhere between f and infinity, that is for sure. They have given the height of the image. So h of the image is given to you as 10 mm. Height of the object is given to you 2.5 mm. One more thing, when they have told the image is real, definitely it will be inverted. When the image is a real image, it will be inverted, and if the image is inverted, height of the image will be negative. If you see carefully, here the image has become enlarged, so I have got an idea that the object is definitely between f and c. I hope you are also able to understand what I am trying to say. They have told that it is placed at 5 cm from the mirror. So u is given as 5 cm, and I told you u is always negative. So you can draw this diagram simultaneously in your rough space like this. This is a concave mirror and this is P, this is F and this is C. They have not given out the value of all these things, but somewhere I have myself located that it is between C and F. So the image will be something like this, and here the image will be formed, and they have given the value of this as 2.5 mm and this is 10 mm. Okay, they have asked, and this is object is placed 5 cm. So this is given as 5 cm. They have asked you to find what is the value of focal length and what is the value of V. Using the formula 1 by f is equal to 1 by v plus 1 by u, will it give the answer to you directly from here? No, because only u is known to you. F and v both are unknown. So directly using this formula will not give you the answer. One more thing I want to put stress here is that whenever you read the question, from the question when you are writing the values in the given data, that time itself you must put the sign convention. If you don't put it here, you will do a mistake. Never put the sign convention in the formula. Put the sign convention only in the values. I should not write minus u here or minus f here, it will give me a wrong answer. So automatically my answers will come in minus or plus, whatever is the required answer. So then how to proceed in this question? We know magnification formula, that is hi by ho. We know that hi by ho is equal to minus v by u. Hi is known, ho is known, u is known. From here you will get the value of v, isn't it? So how much will be the value of v? Let us put the values here. Hi is given as minus 10, ho is given as 2.5, minus v we want to find, u is given as minus 5. So minus minus gets cancelled, and at 2.5 it becomes 4 times. So I get v as minus 20 centimeter, because they both are millimeter, got cancelled, centimeter was remaining here. So I got the value of V as minus 20 centimeter. Now I have the value of V, I have the value of U, I will put here and I will get the value of F. So 1 by F is equal to 1 by V is minus 20 plus 1 by minus 5. So I can write 1 by F is equal to, if you take the LCM as 20, this will be minus 1 plus minus 4, isn't it? So I get 1 by F is equal to minus 5 by 20, so 5 4s are, so I get F is equal to minus 4 centimeter. So I said, automatically you will get the answers in minus, which shows that V is negative, F is negative. So F was 4 centimeter, U is 5 centimeter and V is 20 centimeter. This is what is the answer. So what we came to know? We came to know that in this question, this was given data. Now this value is given, this value you have found and this came to be 20 centimeter, and this the value of F that you have found and that has come to be 4 centimeter. Right? So this is how you have to solve the question. So once again I am repeating you, whenever you are solving any numerical, the moment you write in the given data, in the given data itself you should infuse the values of negative or positive. If you try to put negative or positive in these terms, then you will definitely do a mistake. So never put the negative signs or positive signs in the terms, use only in the values, right? Let us see this question. An object is placed at a large distance in front of a convex mirror of R 40 centimeter, R is radius of curvature. How far is the image behind the mirror? So in this question nothing is given, they have given the value of R as 40 centimeter. If R is 40, what will be F? I said you F is equal to R by 2. So F will be equal to 20 centimeter. And whether it will be positive or negative, it is a convex mirror. I said you whenever it is a convex mirror case, F will certainly be positive, because F is on this side. So if the object is kept here, this distance will be positive. So F is 20 centimeter plus 20, and they have asked you to find the value of V. One thing, since they have told object is at a large distance, that means U will be infinite. Okay, let us use the mirror formula. 1 by F is equal to 1 by V plus 1 by U. So 1 by 20 is equal to 1 by V want to find plus 1 by infinity. 1 by infinity is 0. So I get V is equal to 20 centimeters. See, automatically the answer came in positive. It means object the F is 20. So V also came to be 20. So I told you already, right? You remember? Whenever the object is placed at infinite in front of a convex mirror, the image will be formed at the focus. Isn't it true? By this answer we can understand that. Let us see one more question. An object is placed 15 centimeter from convex mirror of R 90 centimeter. Calculate the position of image and magnification. So in this question, what is given? The given data is the object is placed. So U is given. U is given as 15 centimeter. Remember that U will be negative. Why negative? This is the convex mirror and you are placing the object somewhere here. So definitely it is against the direction of incident ray. So it will be taken as negative. U is minus 15 centimeter. R is given as 90 centimeter. Definitely F will be equal to 45 centimeter. They have asked you to find the position of image, that is V they have asked you to find, and magnification M they have asked you to find. So we know that 1 by F is equal to 1 by V plus 1 by U. So 1 by 45 is equal to 1 by V want to find plus 1 by minus 15. So what will be 1 by V? 1 by V will be equal to 1 by 45. This goes here, becomes positive, plus 1 by 15. Take the LCM as 15. So what you will get? You will get 1 plus 3. So I will get the answer as 1 by V is equal to 4 by 45. So V will be equal to 45 by 4 centimeter. This is the answer for V. And what is the answer for magnification? We know that magnification is equal to minus V by U. So what is V? V is 45 by 4. And what is U? U is minus 15. So minus this minus is cancelled. 15 3s are. So magnification is 3 by 4. Can you see magnification is coming as 0.75. That means the object is diminished. It is smaller. Whatever the object is, the image is 0.75 times of that. Right? This is how you solve the question. So in today's video, what we learned? We learnt what is Mirror's formula. Before telling you Mirror's formula, I have told you what is sign convention of Mirror formula, and two sign conventions were there. I told what is that. Then 1 by f is equal to 1 by v plus 1 by u. Magnification is equal to minus v by u, that is equal to hi by ho, and then I solved some numericals based upon that. Please solve as many numericals as possible. If you solve 50 numericals, you will have more confidence on this chapter. So if you want to become strong in Mirror formula, the only way is to solve more and more questions. I expect you to solve all the questions in the textbook given. Thank you. We will see in the next video about the lenses.